A very good morning to all of you. So the topics of today's discussion is, the first topic is principles of survey design and the concepts of sampling, and the second topic is mixed method research. Now at the end of the session, we'll be all be trying to understand the principles of survey design and what are the concepts and types of sampling, and in the second part of the session, we will be trying to understand what is mixed method research, how to or when to conduct it, and understand the different mixed method designs. So coming to the first topic, that is principles of survey design and concepts of sampling. When all the individuals in the population are selected for any kind of measurement, then the study is called census. We take from each of the individuals in a population, so that is called a census. But when we collect data from only a subset or a sample of population of interest, then we call it sample survey, or most commonly just survey. Now, why do we conduct these surveys? The main advantage of conducting a survey over a census is that there is reduced cost and there is greater speed. Now, why do we need to discuss this under One Health research? Because information on characteristics of human populations, herds, and environmental status is constantly needed by public officials responsible for planning health and social services. Now, we use the term estimation. The objective of a survey is to estimate parameters of the population. This word parameter is the value for population. When we are trying to find the value for a population, then we use the term parameter, and when we are trying to find the value of us from a sample, then we call it statistic. So the objective of a survey is to estimate parameters of the population from that sample that we are collected. So that's why it is called estimate, because we don't know the true value that is in the population, that is unknown to us. So this summary statistics, this sample statistics, from that we try to extrapolate for the entire population. So that's why we use the term estimate. Now, surveys can be broadly classified into field-based study or hospital-based study when we are mostly concerned over public health. But if we see through the lens of veterinary epidemiology, then we can classify into field-based study or slaughter-based study. Now we know that field-based studies have got better representation of the general population, because in hospital-based studies you have higher prevalence of the diseases, or the age distribution is different in hospital or in slaughter-based studies. And there is also another limitation in slaughter-based studies. We are not able to identify or track down the animals that are there in slaughterhouse to their herd of origin, because mostly in low middle income countries we don't have the tracking system. But we have some disadvantages of field based studies also, like it is resource intensive. So we have constraint regarding cost, time, and also administration costs. So coming to the principles of survey, as I was discussing, that the primary objective of a survey is to take a sample from the population and to estimate the population parameter from the sample statistic. So how good is this estimation? How valid or reliable is this extrapolation? That depends on mainly two things. First is how good or how well you have chosen the sample, and second is how well the measurements are. So coming to the first principle, that is how well you have chosen the sample. So that's the sample design. Now sampling methods refer to the techniques used to select a sample from this target population. We can divide it into two ways mainly, that is probability sampling and non-probability sampling. Now under probability sampling, everyone in the population has a known non-zero chance of being included in the sample. And second, we can have unbiased estimates of the population parameter. Now keep this in mind, we have here written known non-zero chance. So everyone has got some chance of being selected, which is known. So let me explain it further. So in probability sampling, what we do is we take a list of all the individuals of the target population, and so we will have a list of all the individuals of a target population. This is a target population. So we'll have individual number 1, individual number 2, individual number 3, 4, like this. Maybe our target population is around 10,000 individuals. So from this list, we'll be selecting some individuals, our sample. So this list is called the sampling frame. And this sampling frame should have the property that each of them has got some chance of being selected. It may not be equal, but it has got some chance, and that chance should also be known. And this selection of sample can be of any method. So this is what is probability sampling, and it will give us an unbiased estimate of the population parameter. Now coming to the second part of the classification, that is the non-probability sampling. Now why do we do non-probability sampling? Mostly because probability sampling is time consuming, expensive, and many a times it's not feasible also. It is subjective, it does not has that randomness concept in it. Based on your convenience, whoever is your neighbor, you'll be selecting that sample. And so the user has no firm method of evaluating either the validity or reliability of the final estimates that we are making. If you see elaborately the non-probability sampling techniques, there are various types under it. First is convenience sampling. That is how it is convenient to the researcher. So suppose the audience that I am teaching right now, from that I want to select a sample, I will be selecting only those individuals who are my neighbors. So I will be selecting those. That is convenience sampling. Now next type we have this purposive sampling. Now this is based on the expert's judgment of what is the study objectives and what is the purpose for which we are going to take the sample. So that depends on the expert and his or her own judgment. The third type is quota sampling. We have predetermined number of units that we will be taking from each of the subpopulation. So that is called quota sampling. I'll be talking about it again in the further slides. And then we have snowball sampling. Now this is done when the respondents are very difficult to find or they are rare to find. Like suppose we want to do a study with 6 workers, then we need to do a snowball sampling. We'll be asking them, they'll be telling us further where are the other, if we need to find other 6 workers. So these are the non-probability sampling techniques. Next we have the probability sampling techniques. Now under this we have most commonly these 4 types of probability sampling techniques: simple, systematic, stratified and cluster. So we'll be talking about each of them. First is simple random sampling. Initially I had told that each one has some probability sampling should have non-zero and known chance. I told that, mark my word, it is not equal. But in simple random sampling, each individual from the population has the same probability. So each one has the same chance of being probability of being selected and enrolled in the study. We usually go with the software programs nowadays, but we also have random number table and lot method in selecting simple random sample. The major limitation of a simple random sample is we need, as I was discussing before, that we need a complete sampling frame for this. We need all the individuals. Most commonly the individuals can be, if we see through the perspective of One Health, it can be human beings or it can be animals also. So I'll be using the word units. So each unit we need each of the units, a list of all the units in the sampling frame, and then from this sampling frame we will be using maybe a lot method and we will be selecting 1 or 2 or how many what is a sample based on a sample size. So the limitation here is we need this list, otherwise we will not be able to do simple random sampling. Second difficulty is, if this sample, suppose sample number 70 we have got here and 80 we have selected 70 and 50. If these samples are spread out, maybe sample number 5 is in North India and sample number 70 is in South India. So you see, if the samples are spread out, then the cost increases in collecting the sample. So for that also, simple random sample, usually we don't go with it. So this was the first simple random sample. Now next is systematic sampling. So as the name suggests, that it has got some fixed plan, systematic, according to some fixed plan. So the initial sampling unit is picked up randomly and then every kth unit is drawn, and every nth or kth unit is drawn. So let me show an example. So here you have 12 individuals, Out of this, my sample size is, let's say, 4. So we need 4 people from this 12 individuals. So for this we need a sampling interval, that is systematically we need to, in a methodical approach, we need to pick up some individuals. So for that we need a sampling interval. So 12, here it's the formula is given, capital N is the total target population that we have, that is 12 individuals in our population, divided by the sample size, that is 4. We need 4 people, so it will be 4, 12 divided by 4, it is 3. So every third individual we need to pick up from the 12 individuals. But keep in mind, the initial sampling unit picked up should be randomly. So maybe you do a lot method or you do a random number table, and the first individual that you selected was serial number 2. So here we have discussed that every third unit you have to take, so third individual. So serial number 2 you will be taking, then serial number 5 you will be taking, 8 and 11. So now you got your 4 individuals. So that's point number 3, that is draw every k units from the first unit. Suppose the one disadvantage that I was talking in simple random sampling was that you need a complete sampling frame, right? Suppose in this example you don't have the full sampling frame, still you can do systematic sampling. So you have a rough idea that how many individuals are there, maybe 12 individuals or 13 individuals, something like that, you have a rough idea. And then first unit that was randomly selected was serial number 4. So then, as we discussed, every third you have to take, right? So 4 plus 3 is 7, 7 plus 3 is 10, and then what we can do is something known as circular sampling. We can again go back to the first individual and we will be selecting this individual. So this is called circular systematic sampling. This was the second type of sampling. Now we have the third type of probability sampling known as stratified random sampling. We classify the population into homogeneous subgroups. Here we can see homogeneous subgroups, that is green individuals, blue, maroon and grey. So each of this strata 1, strata 2, strata 3, strata 4. So we have got 4 strata and each of the strata are homogeneous. They are similar based on a certain condition. Here we have taken color as the condition. So in stratified sampling, what we do, we divide it into strata and then we draw a sample from each strata, and the results of the sample are finally inferred for the whole population. Now when do we do stratified random sampling? When the subpopulations vary greatly, you can see they have different color altogether, and when we need separate conclusion for each of the subgroups. So, and the differences between the subgroups are of some particular interest. So that time we do a stratified random sampling, because we can see, it's visible to us that this whole population has got different colors, so we can divide it into strata. Then if we select from the whole population itself, maybe we will be only selecting the maroon ones, right? In random number table, if we do, maybe only the maroons are being selected, but we don't want that. We want representation from each of the strata. That time we do a stratified sampling. Now stratified sampling can be again, now if you see here, once we have divided into homogeneous subgroups, based on non-probability sampling or based on subjective, I can choose only the first 3 individuals of each of the strata, right? I can choose the first 3, it's based on my own convenience. Then that is called quota sampling. As I was discussing, that I will be coming to this topic once more. So here we have some predetermined units from each of the subgroups. I have decided I will be taking only the first 3 from each of the strata. So the rest of the individuals don't have any known chance also, that is 0 chance, and they don't have, and we don't know about the chance of each of them, so that is comes subjective. So this is called as quota sampling, when from each of the strata you have some predetermined number that you will be taking without any randomness. But what we are discussing now is stratified random sampling. So once we are divided into strata, we can randomly select, maybe suppose in the first strata we will randomly select these 4 individuals, so they have come to our final sample. Now from the second we will be taking 4 individuals, from the using lottery method, from the maroon also will be taking 4 individuals. So from each of them we have taken 4 individuals, irrespective of the size of the strata. So when we are taking equal number is irrespective of the size of each of the strata, then it is called disproportionate stratified random sampling, because it is not based on the proportion, it is based on equal number, so it's not proportionate. But in case if we want to do proportionate, then we need to, suppose, let's take an example, I'll take 50% from each of the strata. If I take 50% from each of the strata, then from the first group 50% from first, so in the first one we have 10 individuals, so we'll be taking 5. In the second one we have around 12 individuals, so 50% of 12 is 6 individuals. In the third we have around 8, 50% of 8 is around 4 individuals. So see here, though the numbers are not equal, but we will be taking equal percentage from each of them. So this is called proportionate stratified random sampling. Coming to the final point, that is the main disadvantage of stratified random sampling, is that the sampling error is very difficult to measure. Now what do you mean by sampling error? Is that sampling error, you can say, is the difference between population parameter and the sample statistic. This difference is actually sampling error. So when we have a population, this is a target population, from this, suppose you have taken a sample 1. Now you are trying to estimate from this sample the true value you are trying to estimate, the value which is unknown to us, that won't be accurate, right? So it will have some error. So that error is the sampling error. Each time you take another sample, you will have close to the estimate or a little further from the estimate of the true value. So each time when you are taking samples, there will be some error in the measurement of the actual value. So that is accounted because of the sample that we have taken. So that is known as sampling error, population parameter minus the sample statistic that we have. Now that can be measured in simple random sampling or in systematic sample random. Why? Because in that you have the whole population, from that you are taking sample. But it's difficult to measure in stratified random sampling and also in the next type, that is cluster sampling. Why? Because we have divided the population into some strata here. So it's very difficult to estimate the sampling error here. Now coming to the final sampling method, that is cluster sampling. Here we select clusters of individuals rather than individuals. Till the last 3 slides, last 3 sampling we checked, we were picking up individuals. Here we will be picking up cluster. So out of these 6 clusters, we have selected 2 clusters randomly. So in case we would have selected serial number 1 and serial number 12, only that individual from these 12 individuals, then it would have been not a cluster sampling. Here we have selected a cluster from individuals rather than individuals are randomly selected. And clusters are naturally, these are like usually defined by geographic boundaries or administrative units. Like suppose a census enumeration block or a ward, these are like administrative units. Clusters can be based on some institutions also, like hospital based, or you can have schools, that can also be a cluster, or a community like a town. So these are like clusters. Whereas strata are defined by age groups or sex. So a particular age, so like the previous slide we saw, we have divided the whole population because we saw that there are variation in their population based on color. So we have divided it into some strata. If we see through the lens of veterinary epidemiology, then cluster sampling is a natural sampling design, because livestock population are typically clusters into herds or flocks. Now again, going through One Health, it's not only in veterinary epidemiology, but also through the One Health you have herds as natural clusters, you have households of villages as natural clusters. So if you have to go through One Health research, cluster sampling will be a very ideal technique, because again herds and households, there are natural clusters. Now how are we going to select these 2 clusters from this 1, 2, 3, 4, 5, 6 clusters? Now there are mainly 2 approaches. One is simple random sampling, you do a lottery method, or from random number table you select any 2 clusters from this 6 clusters. or else we can do based on the size of each of the cluster, that is known as PPS, or probability proportional to size sampling method for clusters. Now we can see here that in the previous example we saw that the strata, in each of the strata, they were all of the same color, they were all similar, they were all homogeneous. But keep in mind that in cluster, each of the clusters should be a reflection of the general population. The variability in each of the clusters should be just like in general population. It should not be, they should not be homogeneous. Okay, though individuals within the same cluster may be may be similar with respect to environmental exposure, nutrition, they are having the same cultural behavior and genetic factors. So this similarity that they have within each of the cluster, that is usually denoted by something known as ICC, intra-cluster correlation coefficient. And this ICC, and average cluster size, that is the number of individuals in each of the clusters, and here we have each cluster has got 2 individuals. So this average cluster size and ICC can be used to calculate the design effect, which helps us in finding out the final sample size that we need. So if the clusters are homogeneous, if they look like a strata itself, like in stratified that we saw, then it may result in large design effect. Design effect will increase, and then your sample size will also increase. And if you don't take care of this design effect from previously, then there will be less precision. So one thing we need to make sure is that the variability in each cluster should be a reflection of the general population. Again, the disadvantage is similar to stratified sampling, is that we cannot find, it's very difficult to find the sampling error in this type of cluster sampling. And finally, we have something known as multi-stage sampling. So when sampling is performed in 2 or more than 2 stages, then we use this type of sampling, because the large population has to be divided into stages to make the sampling process a bit more easier and more practical. So suppose we want to check the immunization status of a large state. So for that, we cannot directly go to the individual level. So for that we need multiple stages for that. So before coming to that, let me tell you one more thing. We have discussed what is a unit in an sampling unit, that is each of the individual that we are picking from that sampling frame, that is what we are calling as units, sampling units. So in the first stage, when we are picking up the sampling units for the first stage, that is called PSUs, primary sampling unit, in the first stage in this multi-stage. And in the final stage, the sampling unit for the final stage, that is called as enumeration unit, the final one. So coming to the this example that we are talking about, if you have to check the immunization status of a large state, we are doing a survey on that, then the sampling frame for the first stage will be the list of districts. For the first stage will be the list of districts. The sampling frame will be the list of districts within this state. So each state will have a list of districts. So that will be our first sampling frame in the first stage. And then once we have, and then so each of the district will be a unit. Each of the district will be a sampling unit, and this is a sampling frame. So once we have selected randomly the districts that we are going to assess on, so next stage, so second stage will be the list of villages in the selected district. Suppose we have selected district 1 and district 2. So district 1 will have all the villages, that will be the sampling frame, and district 10 will also have a sampling frame. So in the second stage, we see the list of villages within each of the districts that were selected at the first stage will be the sampling frame for the second stage. And so each village will be a sampling unit. And in the third stage, what we see here is that the list of households, there will be a list of household 1, 2, 3. Suppose we have selected village number 3 and village number 9. So village number 3 will have a list of households, which will be the sampling frame for this final stage, and each of the household will be the sampling unit. Here this will be our enumeration unit, because this is the last stage of our this multi-stage sampling, and since we are starting with the district, that is we are going to select from the sampling frame of the districts So this will be our first PSU. This will be our primary sampling units, and this will be our enumeration unit, because this will be our final stage. So this is what is, so we do this when we are conducting a large survey for practical issues. So this is multi-stage sampling. Now, as I was talking about in the first slide, that is how good is the estimate depends on how well you have chosen the sample. We have discussed about it. Now next is how good are the measurements. So for the measurement part, we have survey measurements, that is the second principle of doing a survey. We have the subject matter experts, we have the measurement experts. Now they will give their inputs based on preliminary studies, or they will conduct some study to find out the specific measurement values that are needed, and they will design the questionnaire, and based on that they will pre-test it, they will test it, they will modify it, and finally a survey instrument will be prepared. To give an example, let's see through the lens of One Health. Let's take a study in which we want to assess or check the role of commensal bacteria of gut in the spread of antibiotic resistance. So for that we need subject matter experts to tell us, how the stool samples will be collected from children, from animals, from environment. We need measurement experts also who will be telling us that how the lab testing will be done, what are the microbiological and molecular methods for isolation and confirmation of, suppose, let's see, E. coli. Now what antibiotic susceptibility methods are needed for, to find the, like, diffusion methods are needed or not to find the resistance, approaches and procedures for quality control for all these tests, like checking of samples, checking of the swabs, the reference strains and reagents. So the experts need to go through all this literature and do some preliminary studies to finalize a tool. Now that tool they need to again pilot it once, a pilot study to field test those, stool sampling kit that they have prepared, or the sterile containers that they have purchased, or the reagents in the lab they are collecting. So they need to field test it once, and not only that, they need to train the research assistants or data collectors on how to do it, and finally also the participants also may need to be trained on how to collect the sample from the children, or the data collectors on how to collect it from the environment. So all these procedures come under your survey measurements. Once this is done, then finally we have our on-field survey operations, that is collecting of data. Now the operations totally depends on what is the scope of the survey, how big is the sample, how big is the complexity of measurements that we discussed right now. Is it a one-time survey or is it a continuous procedure, continuous survey? Based on that, we'll be recruiting the staff. Earlier we used to have mostly paper and pencil method, but nowadays we usually go with computer assisted interviews. So each of them has got their own advantages and disadvantages. So if you want to go with, you want a high response rate, which is high, then you will usually go with personal interviews, face-to-face interviews. But if you want cost to be as minimum as possible, then we usually go with the self-administered one. You mail to all the participants, they will reply on their own free time. But in that, the response rate is very low, and in the personal interview, the cost is very high. So in between comes the telephonic interviews, in which you have moderate cost, moderate speed. So these are the different types of ways in which you can collect data. And the final principle of conducting a survey is the output that has to be documented somewhere, and that has to be statistically analyzed and written in a proper format. So before that, we need to always supervise the data entry that is happening from the field or in the after coming from the field. So data entry supervision is important. So is also important is the confidentiality of the data, not only in collection of data of the participants, and also during the data analysis time. And appropriate software needs to be chosen for the data analysis. After the data have been collected, coded, edited, processed, finally the analysis is done statistically, and we incorporate the findings into a final report. Initial part of the report, the results, we usually write about what are the different measures of central tendency and dispersion in the sample that we have collected, that is the descriptive statistics, and based on the appropriate statistical tests, we do the inferential statistics and we estimate the characteristics of the population from the sample that we have collected. So, of the total, we try to estimate of the population from the sample that we have, sample statistic population parameter. So, now last point is very important. We need to be very cautious in interpreting. Why? Because estimates, these estimates that we have got from the sample statistics for the whole population, they are subjected to both sampling error that we had talked before and also measurement error. The instruments that we are using, are they validated or not, are they checked or not before using. So they are subjected to both sampling error and measurement errors. The main 2 points that I told are the key points for the validity or reliability of the sample that we have. So they are subject to this kind of errors, and any interpretation of the findings should take into account these errors. So these are the 4 principles of survey that we were discussing till now. So if you need to summarize it, so I discussed that the students must be able to understand the principles of survey design. So the principles of survey design, if you have to see, so first is how good the sample was chosen, so sample design. Next is your how good the measurements were, so survey measurements, how good the survey measurements, they're validated and they're reliable or not. Third is your, as we discussed, the final operations, that is the survey operations. And finally is your statistical analysis and report writing. So these are the main principles of a survey design. And concept and types of sampling, we had discussed it. So these are mainly 2 types, non-probability and probability. Under non-probability, we have the purposive, convenience, quota and snowball. And under the probability sampling, you have simple, random, systematic, cluster and stratified sampling. This is the summary for the first part of the session. Now let's come to the second part of today's discussion, that is mixed method research. Nowadays it is usually called the new star in the social science sky, or the third research paradigm, because after the development of the quantitative and then qualitative research, this mixed method research has come. Usually it is defined as a type of research in which a team of researchers combine elements of both qualitative and quantitative research for the purpose of understanding both the breadth and depth of a research question or a hypothesis. So to simply explain, so in the researcher actually collects and analyzes rigorously both the qualitative and quantitative data, giving priority to either both or one of this data set, and then finally mixes it in concurrently or sequentially or embeds one within the other one. So we have both quantitative and qualitative, which either we give priority to each of them equally or we give priority to one more than the other, and we conduct them either parallelly or one within the another, or we do it one after the another. We will be talking about it more. So when to conduct a mixed method study design? First, when you have both qualitative and quantitative data and together they are strong. They are stronger when they are together. So we know that qualitative data provide a detailed understanding of a problem because we are studying a few individuals. So it gives us more of a depth, as was the definition, depth of understanding. And quantitative data gives us more of a general understanding of a problem because we are examining a large number of people. So mostly it gives us the breadth of it. So that's the first criteria when to conduct a mixed method design, when we need both and both are stronger. Next is when one type of research is not enough, when you wish to have alternate perspectives of the study in a study. So there are times when qualitative study design is best when we need to explore a problem, give voices or honor the voices of participants, map the complexity of the problem, give a theoretical stance to the problem, then we need a qualitative study. At other times, we need quantitative research when we want to find the relationship among variables, to find out if one group is better than another group. So we need mixed method when we need to explain the quantitative study results, we need explanation depth regarding the quantitative study results, and when we need to generalize the exploratory findings. So when we need to generalize this depth of understanding, that is the qualitative part, when we need to generalize it to everyone, we need breadth for this depth, and when we need depth for this breadth, that is when we need the results to be explained. We have this quantitative study, we have found breadth of it, and we need depth inside it. We need that explanation, the quantitative studies to be more explained. Then in this kind of situations, when we need alternative perspectives, when one study is not enough, then we go for a mixed method design. And finally, this is very well suited for something like One Health, where we have interdisciplinary research. So in One Health, we have scholars from so many other fields like epidemiologists we need, veterinarians we need, environmental engineers we need, ecologists, climatologists, botanists, microbiologists. So we have scholars from so many different fields of study in One Health. So mixed method is actually very suited for something like One Health, because it enables researchers to employ multiple philosophical perspectives that guide this research or a study. So coming to the different types of mixed method designs that we have, these are the following are the 6 types of mixed method designs that we commonly encounter. We'll be talking about each of them now. So first type, convergent parallel design. So as the name suggests, it's going to converge. So we have here quantitative data, we collect it, we analyze it. We have qualitative data, we collect it, we analyze it. So here what we are doing here is, we are prioritizing each of the method, quantitative and qualitative, equally. They are going independently. We are conducting both this independently, and we are also merging the results, and we are, even before the results, obviously we are going to analyze them also independently, and then finally we mix the results, and overall during the interpretation time we mix the results during the final interpretation. We merge the quantitative results and the qualitative findings, and then we mix the results during the overall interpretation time. Two separate arms, they are going concurrently, parallelly. We merge the results, and finally during the interpretation time we merge the results and we try to interpret the final findings or results. To take an example, let's see. Suppose there are formal and informal healthcare providers. We have healthcare providers. We want to understand their attitude towards antibiotic usage. What are their attitudes? We want to find out their attitudes towards antibiotic usage. So as a researcher, we'll parallelly do a quantitative survey. So we'll do a survey among all the healthcare providers. We'll try to find out. We'll analyze the survey. Maybe we'll be taking 100 healthcare physicians. We'll be based on a questionnaire. We'll be trying to find out quantitatively what do they have the attitude towards antibiotic usage, and among those 100 people only, we'll be doing a qualitative data collection till we are attaining data saturation. So these two are going parallelly, trying to understand the attitude towards antibiotic usage. Now we'll be doing the analysis also separately, focus group discussion here and here a survey going on. So we'll be doing the analysis also separately, and then finally we will be trying to find out in what way the physicians' attitudes, after checking their results and findings, and finally we'll be interpreting in what way do the attitudes converge and diverge. So why do we do this? Here we are trying to, because each of them gives a partial view. So to have a complete understanding, by collecting both the quantitative and qualitative data, we are trying to find out what are the attitudes. So each of them gives us a partial view. So it's like half plus half gives a full 1. So circumstances or studies regarding this usually go for convergent parallel design, when it's giving us a partial view by going only by doing one type of study design. Coming to the next type, now the next two types are sequential designs. The first one was parallelly, each of the strands were going parallelly. In this one, each of them are going sequentially. So the first one is explanatory sequential design. Explain. So it's the key word here is explain. So we'll be collecting and analyzing quantitative data. We'll follow them up with qualitative data, and finally we'll be interpreting it. So here the qualitative results are actually trying to explain the initial quantitative results that we have got. From quantitative data we will getting some results, but we need explanation for that. That's why I told the key term here is explanation. We need explanation for that, and for that we are doing a qualitative study, and so finally we will be interpreting the final mixed method study based on the interpretation. So let's go continue with the previous example. We want to find out what are the significant predictors for antibiotic abuse. Antibiotic abuse among the healthcare providers that we were discussing previously. So what are the significant predictors for this abuse? So maybe while doing a quantitative study, surprisingly we found that maybe private practice has got some association with antibiotic use. It has got some association with antibiotic usage. So to explain this, we need to do a qualitative study, and we may not do among the same individuals that we got. We will be doing only among the people who are practicing private, healthcare providers among in the private practice. We will be trying to understand why they are excessively using antibiotics. So why we are doing this kind of studies? Because it gives us in detail the participants' voice, the participants' perspectives, to tell us what are the mechanisms for such a trend, why this significant association happened. To understand the mechanism, we went through a qualitative study design after doing a quantitative research. Next comes is exploratory sequential design. Again here it's a sequence. So first you will be going with since it's an exploratory study, so first we will be going with qualitative data, you explore it, you build it up to finally do a quantitative study design, and then the final interpretation. So here we build from the qualitative results to do a second quantitative study design to generalize what we found in the qualitative findings, qualitative research. Continuing from the previous example, suppose we want to restrict antibiotic usage. We want to restrict it. So we do a qualitative study, FGDs or some IDIs among the healthcare physicians, and listen to the different stories that they are telling, that how they attempted to restrict the usage of antibiotics. So we got those results, we identified some context, we identified some strategies, and then those strategies obviously will be some variables. We make it into some variables, make a study instrument, and then we conduct a survey to find out, to assess what is the overall prevalence of those strategies or those variables among all the healthcare physicians who are using antibiotic usage excessively. So what we did here is, we got qualitative data, we found the results, we found the stories, of how they have tried to restrict themselves, we found some strategies that they have used to restrict themselves, and we checked if those strategies, how prevalent are those strategies in the general population. So that is exploratory. We started with exploratory and then we checked it among all the healthcare physicians. This is the third type of study design. Coming to the fourth type, embedded. As the name suggests, so it is embedded within the other type of study design. So if we are doing, so here the term strand means any component of a study design. So any component of a study, it may be the research question, it may be collecting of data, it may be analyzing data, it can be interpreting the results. So these are all different components. So these are called a strand. So suppose we have a quantitative design like an experiment or RCT, let's give an example. So in that RCT, if you add a qualitative strand, like if you do a FGD inside an RCT, then we usually say it's an embedded design. Or we may add, suppose we are doing a qualitative study, qualitative research, a case study is going on, and inside that we add a quantitative strand. So that is also an embedded design. So continuing from the previous example, healthcare physician, suppose we found out a strategy in the previous, and that strategy is quite prevalent in many of the communities. So we want to check if the strategy actually works or not. So we are doing an RCT intervention. Now we have put the strategy to restrict antibiotic usage among the healthcare physician. So one arm, so it will be two arm. One arm will be the intervention arm where we have put the strategy, and the other arm will be the control arm. So while doing this RCT, in the intervention arm, when we are putting the strategy that we discussed, we may conduct a FGD among healthcare providers, and we may take their views, we may explore their views on the new strategy and find out if they are comfortable with the new strategy or not, or what are their views on the delivery of the intervention. So this is a qualitative component that we've added in a quantitative study design. So this is a fourth type of study design under mixed method. The fifth one is transformative design. So if a researcher shapes the study within a transformative theoretical framework, it may not be quantitative followed by qualitative, or it may be qualitative followed by quantitative. The sequence does not matter, but there has to be a sequence. So for that kind of a transformative framework, we call it a transformative design. So it is usually done to lift the voices of participants against the challenges of social injustice, or to bring about a change for a marginalized group. Many of the studies have been done in South Africa for focusing on both the magnitude, that is the breadth that we discussed previously, and the depth of the issues. Like for the magnitude of social injustice, so using quantitative approach, and also to try to understand the participants' perspectives using the qualitative approach, that is the depth. So let's give an example. In one of the studies that I was going through, what they had done was to check the social injustice of water accessibility. They found the magnitude of water access is more among the urban community compared to rural community. So rural people had less access of water, and so that they have found quantitatively, and then they followed it up with a qualitative study component to lift the voices of the people in the rural community, to understand their perspective, or to lift the voices of the participants regarding their basic, right for basic service access, that is water here, so that people get to know what is their view, that what are the problems they are facing, and what is their right regarding basic water access. So here we have both the quantitative and qualitative study design. Finally, we have this multi-phase design. It combines both sequential and concurrent strands over a period of time. This multi-phase design is usually done when we have sufficient resources, funding, and many times even a single mixed method is not enough. We need to do two mixed method study designs. There's all this at different levels of program, at the primary level, at the policy level. So this is usually approach done when we want to do a program evaluation. So that kind of approach, for that we need multi-phase design. We will do a qualitative component, try to find out where are the lacunae, where are the problems. Then based on that, we may need to do quantitative study, or again we may need to do a qualitative study among the different levels of health system, and then finally do a mixed method study design to find out where are the problems and how to solve it in a program evaluation. So coming to the summary for the second session, what is a mixed method research? We had discussed this. Let's see the definition one more. That we should have both the breadth and depth of understanding. That is, we should have the quantitative part, quant, and the qualitative part in the study. So we should be able to collect and analyze both qualitative and quantitative data, giving priority to one or both at the same time, and they can be going sequentially or parallelly or embedding one within the other. So that is what is mixed method research. When to conduct it, we discussed that usually when we have both qualitative and quantitative data and together they are stronger. When one type of research is not enough, when we need a different perspective also, and it is really good, well suited for interdisciplinary research like One Health. And finally, what are the different types of study design, what are the different types of mixed method designs under it. So we have convergent parallel, we have explanatory and exploratory sequential design, we have embedded design, we have transformative design, and finally multi-phase design. This is the summary for the second phase. Thank you.